Hello, well in lesson 3 we're going to look at a couple examples on dividing polynomials. We're going to do 4 examples. First 2 will be just working with a couple monomials. Then the second one we're going to take, or third and fourth, we'll take a polynomial and divide it by a monomial. We'll just be following exponent laws as we did before with multiplying polynomials. So example number 1. First thing we're going to do is just take a monomial, 25x cubed y to the 4th, z to squared, and we're going to divide it by negative 5 x y squared z. Pretty straightforward. Our exponent laws tell us that when you divide same bases, you will subtract exponents. So we're going to just subtract the exponents in this case. Take care of the coefficients. 25 divided by negative 5 will be negative 5. X cubed divided by x will give you x squared. Y to the 4th divided by y squared will give you y squared. Z squared divided by z, again subtract exponents. So your answer will be negative 5 x squared y squared z. Quick application of exponent laws. Same basis, when you divide, you will subtract exponents. One more monomial, make it a little bit tougher. Example number 2. We're going to take 3a to the negative 2 b squared c cubed to the power negative 2, and we're going to divide it by 2a squared c to the negative 1. Now there's actually quite a few different ways we can look at this. You could do your power of a power first and then start to subtract. Sometimes what people like to do is, as soon as you see entire expressions to a negative exponent, they like to reciprocal those right away so that they're working with positive exponents. It really doesn't matter. You need to go with what your strength is in this. If you have a tough time subtracting negatives, well then maybe you want to move these two terms from top to bottom first so that you don't make mistakes subtracting negatives. What I would probably do in this one is I would take each term and move it from top to bottom. So I would write this as 2a squared c to the power 1, and I would divide it by 3a to the negative 2 b squared c cubed to the power 2. I will take away quite a few of the negative exponents that would have came from using power of a power. Now I'm going to simplify this again. Write this as basically 2a squared c, because anything to the power 1 is itself, over 3 squared gives you 9. A to the negative 2 to the power 2 means multiply to give you a to the negative 4. B to the 4, and C to the 6. And again, when we finish this off, you will subtract exponents when you divide, so we'll be left here with 2/9. And we got a squared minus a negative 4 will be, so add 4, so that'll give you a to the 6 on the top. C on positive 1 subtract 6 will give you c to the negative 5, or we can move it down to the bottom and write it as c to the 5. And there's no b on the top, and we're still left with a b on the bottom, b to the 4th. The other way of writing this, again, if you didn't want to write it with variables in the denominator, we could write this as 2/9 a to the 6, b to the negative 4, c to the negative 5. And notice when you see how I write it the two different ways, that when you reciprocal the base, meaning move from top to bottom, you will change the sign on the exponent. And it's really important to get the hang of that. Sometimes you'll want to write expressions with no variables in the denominator. Sometimes they'll ask you to write expressions with positive exponents. So depending on how you're being asked to write your answer, you need to know both ways to do this. But they are equivalent. So there's a couple monomials dividing and just using exponent laws. In this case, I used power of a power, negative exponent law, and dividing powers. When you use power of a power, you multiply exponents. When you use negative exponent law, you reciprocal. When you're using dividing powers, you will subtract exponents. For our third example, let's take a polynomial, more than one term, and we'll divide it by a monomial. In this course, we're only going to divide by monomials. We won't go into dividing by binomials. We just need to know how to divide by a monomial so that when we do factoring in the next lesson, we can use division. Now, when you divide polynomials by a monomial, we are now going to be a little bit more concerned with restrictions. So my first example, I have a trinomial, 28x cubed minus 16x squared plus 10x, and we're going to divide it by 2x. Now what this means is you divide every term by 2x. So it's really 28x cubed divided by 2x minus 16x squared divided by 2x plus 10x divided by 2x. 2x goes into every single term of this expression. So let's simplify. 28 divided by 2 gives us 14. X cubed divided by x gives us x squared. 16 divided by 2 will give us minus 8. Again, x squared divided by x will give us x. And 10x divided by 2x will give us plus 5. Now, a lot of times you're going to be asked to state the restrictions. So when you're stating restrictions, this means that you are not allowed to divide by 0. So anytime you have something in the denominator, you have to set that not equal to 0 and solve for the variable. Because the variable is not allowed to. When you divide by 0, your expression becomes undefined. So in this case, when 2x cannot be 0, that means that x cannot be 0. If x was 0 in this question, you would end up dividing by 2 times 0, which is 0. And if you divide by 0, this thing's undefined. So x can be any other number except 0. And that's what it means to state restrictions. So we usually write the answer, and then beside it, we usually put what the restrictions on our variable are. Now, go with the rule that when you're doing this, only state restrictions when being asked. Otherwise, sometimes you'll deal with some really complicated restrictions. It's important to get used to restrictions early because we're going to deal with rationals in a couple lessons, and there will be more complicated restrictions when we get to that. Most of the time, our restrictions in this lesson will just be whatever our variable is can't be 0 because there's only a monomial in the denominator. Had we had binomials or trinomials in the denominator, then they'd be a little bit harder to find our restrictions. But since we're only dividing by a monomial or a single term, generally your restriction is your variable cannot be equal to 0. So that's example number 3. Our last one, we'll just make another trinomial, make it a little bit harder by bringing in a second variable, but very similar. Example number 4, we're going to look at 12 x squared y cubed subtract 15 x to the 4th y squared subtract 18 x to the 5 y to the 4, and we're going to divide this trinomial by -3 x squared y squared. So again, we're just going to practice our exponent laws and watch our signs. So again, I'll write this as 12 x squared y cubed divided by -3 x squared y squared minus 15 x to the 4th y squared over -3 x squared y squared, and then minus 18 x to the 5 y to the 4th over -3 x squared y squared. Divide out each term. 12 divided by -3 will give us -4. X squared divided by x squared gives you 1. Y cubed divided by y squared will give you -4y. -15 divided by -3 will give us +5. X to the 4th divided by x squared will give us x squared. Y squared divided by y squared will give us 1. -18 divided by -3 will give us +6. X to the 5 divided by x squared will give us x cubed. Y to the 4th divided by y squared will give us y squared. Again, we need to state our restrictions. Now this one might look a little bit weird, but our restrictions again are our denominator cannot be equal to 0. So we're going to apply a little bit of logic to this. Again, because this is a monomial, if x was 0 in this case, that whole expression would be 0. So therefore, x cannot be 0. If y was 0, again, this whole thing would be 0. So again, because this is doesn't matter what the coefficient is out front, we're multiplying here. So if x was 0, the whole thing is 0. Y was 0, the whole thing was 0. So each variable in this case cannot be 0. X cannot be 0. Y cannot be 0. So that means if we were to do a substitution into here, we cannot use 0 for x or y. Otherwise, this expression would be undefined.